Yeah, it's a pleasure to be here, and thanks for coming. So my talk is about reactive extensions in JUCE, and reactive extensions can be abbreviated as just RX, so that's what I'm going to call it. And I would first like to take a look at what RX actually is, because it's like a buzzword that's floating around the internet and you hear it everywhere, and then there's React and all these kind of things. So basically RX is a programming style for bindings between whatever you want. So if you have worked with JUCE's value listener before, it's kind of similar to that, but has some advantages which I would like to show. And there's one main class in RX, it's called Observable, and the other one is called Observer. So if that sounds like the observer pattern to you, maybe, then you're right on, because it's a solution to the observer pattern. And the nice thing about RX is that it's language independent, so the class names and method names are all the same, even if you go to RxJava, RxJS, RX.NET, and that makes it easy to learn this kind of language or the names, and you can use them wherever you want. So in C++, we have one library from Microsoft Open Technologies, which is called RxCpp. It's really good, and it's a header-only library that uses a lot of template metaprogramming. And they have done that, I assume, to have no compromises in runtime performance. And it gives you all the basic classes you need and a lot of advanced stuff as well. And I actually used this library in one application I did last year, and it worked very well for me. It reduced the bugs. And one problem I found was with the compile times, because I profiled a little and I found that the compiler took a very long time for instantiating templates and figuring out what should happen. So I thought I should improve on that or find a way to work around it. And I created a JUCE module, which is called Reactive, and it uses RxCpp under the hood. It's a kind of wrapper around it, and it solves the problem with the compile times. If you're interested in how, I can talk about that after the talk, but it's a little complicated. And it also gives you connections with JUCE classes, so it makes it easier to use with JUCE classes like button, slider, and label. So without further ado, I would like to go into an example, and because it's always easy to talk theoretically about what RX is, and I want to show how it can help us. So this example is kind of a distortion plugin, and you have one slider where you can control the distortion amount, and then there's a turbo button which amplifies the amount of distortion. And then in the bottom we have a label, in this case, that tells you how hard the distortion is. But you could easily imagine that this could be a picture of a tube that starts glowing or something like that, if you prefer. So one way to do this using JUCE would be like this. You create your main component, and first you add your slider as a member variable, and you want to react to changes from the slider. So you inherit from slider listener and override the slider value changed member function. So that's the usual pattern. And next we are going to add the label. So we add a member variable, and then in our slider value changed, we call an update function, and in that function we first get the slider value and we pipe it through a function called drive2string, which is at the bottom here. And this function takes a double, returns a string, so that gives us a description like moderate or subtle we just saw. So this works, right? Done? Not quite. I forgot the initial update, because if I don't do that, then the label will not have any text until I move the slider for the first time. So that's something I tended to forget, and it made me think about that I should maybe do something different. So if we add the button, we have similar patterns as before. We inherit from button listener and add ourselves as a listener. Of course, we have the member variable here, and then we override button state changed and call update from there too. Okay? So in the update member function, we now get the drive value, get the toggle state of the button, and we have a new function here, apply turbo, which I didn't implement, but you can imagine how it works. You pass in the drive and the turbo, and it will return a turbo that is higher if the drive is true, the turbo is true. So, and then the rest is the same. We call drive to string and set the label text. So this is okay, and it works well. But in my case, I repeated this over and over again, and I was just looking for ways to abstract it or find some layer in between so I don't have to repeat it. So let's look at it from a higher perspective next and have a block diagram. I'm sure you DSP guys and I as well, so we love block diagrams. So here we have the drive and the turbo, and they go into this apply turbo function. The result of that goes to drive to string, and the result of that goes to the label text. And from here, we can do this, get rid of one arrow, and there's this combine latest. And then we get rid of this arrow and just write map. And then we get rid of that arrow and write subscribe. Okay. And then let's just put that in the constructor, and we're done. So one other thing we have to do here is to write reactive label, reactive slider, reactive toggle button. And this is provided by my JUCE module. And a reactive label is just like a JUCE label, but it also gives you the member variable RX. And you can use that to access various things. In this case, we access the value, the toggle state, and the text. So this has the same effect as the other code, and I prefer it, but both have like the same result. So let's look at what's going on here, because there's this dot chain notation, and it would be interesting to know what the types actually are and what's happening there. So first of all, we can create a local variable like this. So this drive Rx value is an observable double. Okay? And we can do the same for the toggle state, which is an observable bool. And an observable just emits values over time. So if we have a timeline like this, then we can imagine that different values appear asynchronously. For example, if we move the slider, then it will generate values like 0, 1, 1 point something, 2. And the observable emits these values. And then the next step we can do is we can combine two observables into a new observable. So as you can see, the combine latest is a method on the observable class. And it can be called in different ways, but in this case, the first parameter is a function, and the second parameter is another observable. And what this does is, whenever either dr or tb emits a new value, it calls the apply turbo function with both values, and that gives a result. And then the new observable emits that result. So in other words, this observable double matches this parameter down here. And this bool observable matches this parameter. And since it returns a double, our combine latest returns a double. The important thing to know here is that combine latest does not actually call apply turbo. All we are doing here is wiring up components. So here no calculation takes place. This is done later on, which I will get into in a second. One other thing we can do is create another local variable, and this is a result of calling map. And here it's similar to combine latest. We have the drive to string function, and it takes a double, which matches this observable here. And since drive to string returns a string, the resulting observable is an observable string. And again, here nothing really happens. It's just wiring up behind the scenes, and it's not calling drive to string yet. Combine latest and map are called operators, and operators, it sounds fancy, and we think of operator overloading or asterisk or double equals or something like that. But in Rx, an operator is just a method on the observable class, nothing more. And every operator takes some arguments, but always operators return a new observable. And this is really handy because it makes things very composable, because you always get the same type back, and you can work with that to get something new. So finally, we can create another local variable, and here we see that the description.rx.text is an observer. So an observer is something that receives the values from an observable. And the observable st has a method subscribe, which takes an observer. And subscribe means that whenever st generates new values, the label text observer will receive these values. And the description rx text, whenever it receives a value, it calls JUCE label set text. So this is how it's wired up. So observers just receive values from observables. Okay, let's take a look at some code here. This is kind of what the observable class looks like. There's a lot more down below, different operators, which I didn't list here to keep things short. And as you can see, map is just a method, and it takes a function here, and the function converts from the observable type to some type u, and the result of map is an observable u. So for example, here t is double and u would be string. And then there's the method subscribe, which takes an observer, and of course the observer type has to match the observable. You need the right kind of observer to call subscribe. And we can also see that it returns a subscription. So I'm not going too far into that, but a subscription is used for unsubscribing later on. If you don't want to receive any more values, you can call unsubscribe on the subscription. And there's also some RAII techniques to automate this. You don't have to do it by hand. So the other class is observer. This is pretty simple. If we think of it as an interface, this is not the actual code, but it looks like this. And it has a method on next, and that receives the value of type t and does something with it. So one other thing that's very useful is the subject, which is just an observer and an observable. And this is handy because it connects the both sides. So because it's an observer, you can call on next on it, and whenever you do, the observable side emits the value you pass to on next. So that's kind of like a proxy between the two. And yeah, so for example, we can create a subject of integers and call it numbers. And we can subscribe. Here we are using a lambda, which is also possible instead of an observer. And we can call on next on the subject with 17, and this will just call the lambda. So that's how subjects work. So if this sounds really familiar to you, then you're right. It's kind of similar to JUCE in that JUCE's value is similar to the subject, JUCE's value listener is similar to an observer, add listener is similar to subscribe, and the value changed method is similar to onNext. So why do we use Rx? And the answer is because of all the operators. It's easier to combine values and to compose new values from them, whereas otherwise you would have to call setters from different places, or you would call some update method like we saw earlier. So that's the main advantage here. So maybe you're asking yourself, how about audio and MIDI? What can we do about that? Because what I've shown now is just GUI stuff, and most of us are probably doing applications that involve audio and MIDI as well, and multi-threading, real-time stuff. So the first thing is, if you are starting on a real-time thread and you are targeting or ending on a real-time thread, I would not use Rx for that, and use MIDI keyboard state, MIDI message collector, and these classes instead. And the reason is that Rx is kind of a high-level style of programming, and it's more declarative, and it uses locks internally. So in some cases it can be hard to see, or rather to guarantee that nothing can lock or no memory can be allocated under any circumstances, because you're not really working close to the metal. So in this case I would not use Rx. But if you want to go from a real-time thread to the main thread, for example, or a JUCE message thread, this is possible, and you may need it if you're doing an oscilloscope or a spectrum analyzer where you have some data on the audio thread and you want to push it up to the main thread. There's a class called LockFree Source, which guarantees that pushing into it does not lock, and the lock-free source is an observable, so you can then subscribe on the main thread and do all kinds of work there. And the other way around is possible as well, and this is called LockFree Target in my JUCE module. So if you have data on the main thread, like a parameter change or a slider movement, and you want to do something with it on the real-time thread, you can use this class. And it looks like this. As you can see, it is an observer, so it can receive values from Rx. And whenever it receives a value, it puts it in a queue. And on the audio thread, you can then use these methods here to dequeue values, either all of them, or if you call try dequeue all, you just get the last value. And the methods here, they return true if there were actually values in the queue. The reason for this strange parameter style here is that I want to prevent copying. That's why it doesn't really return a value. So, for example, if you have something expensive and you don't want it to be copied under any circumstances, you can pass a reference here, and it will use either copy assignment or move assignment if you have it. So that's how you can prevent copies on the audio thread there. Okay, so if you are interested in this and want to find out more about Rx, one very good website is this one, reactivex.io, and they have a sort of a wizard that points you to the right operator. So you can say you have some observables and you want to combine them and output a value computed from the sources using the latest value of each source whenever any source emits, and it tells you you need combine latest. So that's really handy when you're starting out and trying to find the right operator for the job. And another good website is this, RX Marbles. It shows you basically two observables and the resulting observable, and you can drag around the values and it shows you what will happen. So that's it. Thank you. And this is the link to my library, my JUCE module. If you want to try it, it's MIT licensed, so you can use it for whatever you like. And thank you.
Any questions?
Just a short question. Do you have examples in your library, like easy to follow examples where we can see, like just like this one which you showed at the beginning, so we can know how to use your code? And
yes, on GitHub I have an example and tutorial which is similar to what I just showed, the slider button thing, and all the public classes are documented using Doxygen, so there's a link to an API reference. And then there's also a lot of unit tests, actually, and they demonstrate how to use the classes. But I would start with reading the GitHub README. It's pretty long and explains the basics.
Yeah, thank you.
Any other questions?
I was wondering. Oh, sorry. I was wondering. Yesterday, I've seen the talk about the value. What's it called?
Value trees.
Value tree. Value tree. To my understanding, the concepts are pretty similar. Have you ever thought about extending the value tree with the reactive component?
I've thought about it. What I have is, if you have a JUCE value, like in a value tree, you can make an observable from it. So that's easy. I did not hack the value tree in any way because I don't know how easy it is to get it merged into JUCE, and I needed something I could use in my projects right now. I think they cover some common ground. I'm not sure how easy it is to compose values with each other, as we've seen here with combine latest and converting one value into another using some function. I haven't really used them for that.
All right, thanks.
I have a question.
Okay.
Can you use it for lists and collections and stuff like that?
So you mean you have a list and you want to iterate over the list?
So what I mean is you have, let's say, an observable list of objects.
Yes. There are no limitations on the type of you have in your observable other than it has to be copy or move constructible, I think. So it works for pretty much any type. It could be a list of a list of a list of something.
Right, but let's say if I have this list and then I make it observable and then I add something to this list.
Yeah, in that case, you would be forced to make a copy with the new element, yes. Because the way this works, for example, with map, you need to return a new list in this case, and yeah, so if performance is that critical or for some other reason you can't do it, you have to find a way around. I'm not sure how, but yeah.
Any other questions?
I think in the JavaScript world, immutable collections are becoming quite popular for that reason, which have shared data. And I also saw a talk about a guy, I forget his name, who is writing a library of immutable collections with data sharing for C++. So maybe these could be combined together. Just thought I'd comment.
Yeah, that's a good idea, yeah.
Anyone else?
Just wondered if you can currently use the JUCE variant as an observable, or is that the same as the value?
You mean an observable var?
Yes.
Yes, of course.
Okay.
You can do that.
Cool.
And you can also, due to the way how var works, if you then map over your observable var, you can pass a lambda taking an int, because var can convert to int. So that's pretty handy in some cases. Yeah.
Cool. Thank you.
I think that was it, and we have to wrap it all. Thank you very much, Martin.
Thank you.